Hello guys, we're back with you. Please remember to like and subscribe the videos. Subscribe to the videos. Alright, today we're going to be looking at how we derive the double angle formulas. Alright, now to derive a double angle formula, we start with a compound angle formula. And let us start out with sine. So if you recall, for sine of A plus B, we get sine A cosine B plus a cosine of A and a sine of B. All right. And when you have sine A cosine B, that is commutative, so we can practically write it in any order. It wouldn't really matter. Now, how do I get this double angle formula? All right, we're gonna say let B equal A, which simply means that I'm replacing my B with A. Now, when I do that, I'm gonna end up having sine of A plus A. All right. I'm also gonna replace this on the right hand side because I'm replacing all the B's by A's. So I'm gonna have sine A cosine A plus cosine A sine A. Now, when I examine the right hand side here, I notice that I have like terms. Also, sine of A plus A would give me the sine of 2A. And on the right hand side there, I'm going to have 2 sine A cosine A. And this is the double angle formula for the sine. Now the question is, how do I apply this, right? So what if I had sine 4a? How would I utilize this double angle formula? Now I could write sine 4a as a sine of 2 times 2a. All right. Now by comparison, since it says sine 2a, I can now replace my a with 2a. So ultimately it's going to become sine 4a equal to sine 2a. I'm replacing that a by 2a and replacing the other a by 2a as well. So I'm going to have the cosine of 2a. All right. Let us say we had something like the sine of a. That too, I could write it as the sine of 2 times a over 2, which means that now I'm going to replace my a by a over 2 in my original formula. So I'm going to have sine a equal to sine a over 2 cosine a over 2. Okay, let's move to the double angle formula for cosine. All right, so once again, we start off with a compound angle formula that says a cosine of A plus B is equal to the cosine of A cosine of B minus the sine of A sine of B. All right, and you can even pause the video and go ahead and derive this for yourself. Recall we said let B equal A. So I'm gonna have the cosine of, by now you know that this is gonna be 2a equal cosine A minus sine A sine A. Now what happens here when I multiply the cosine of A by the cosine of A? I'm gonna have the cosine of 2a equal cos squared A minus sine squared A. Alright? And that is my first identity for my double angle formula for cosine. But as you know, I'm seeing cos squared A here and I'm seeing sine squared A here, which means that there is a lot of other things that can happen. If we do recall, that cos squared A is equal to 1 minus sine squared A, which means that I can actually take out the cos squared A and introduce 1 minus sine squared A. So this is going to ultimately become cos 2a equal 1 minus sine squared A minus sine squared A. All right, let me change back my color here. So I'm gonna have cos 2a equal, and I'm seeing the like terms here, the sine squared A and the sine squared A. So I have 1 minus 2 sine squared A. And this again is a manipulation of that identity. All right. Now, let us go back again. Instead of going cos squared a equal 1 minus sine squared. Now, instead of going cos squared a equal 1 minus sine squared a, I could have gone sine squared a equal 1 minus cos squared a. All right. So going back to this identity up here, I could replace the sine squared a by 1 minus cos squared a. All right. So this would become cos 2a equal, let me scroll down here, cos squared a minus 1 minus cos squared a. Now, when I break this down, I'm going to have cos 2a equal cos squared a minus 1 plus cos squared a. Once again, we have like terms here because the cosine squared a and the cosine squared a are like term and they are positive. So we could say that the cosine of 2a is equal to 2 cosine squared a minus 1. And this would be a next modification of the identity. Now, what about the compound angle formula for tan? How can I manipulate that to get the double angle formula? All right, so we're going to have it that, recall that the tan of a plus b is equal to the tangent of a plus the tangent of b over 1 minus the product of the two of them. So we have tan a, tan b. All right. Now again, if we go let b equal a, we're going to have tan 2a equal tan a plus tan a all over 1 minus tan a, tan a. Alright, so in my numerator, there we have like terms. So we're going to have tan 2a equal 2 tan a all over 1 minus. And notice that that is tan a times tan a. So by laws of indices, we have tan squared a. Alright, now here's an example. So I am being asked to prove that 1 minus cos 2a over the sine of 2a is equivalent to tan a. Alright, so remember with proofs, we first need to decide which side we're going to be taking. So I'm going to be taking the left hand side. So taking the left hand side, which is abbreviated LHS. Now the left hand side here is 1 minus cos 2a over the sine of 2a. Now it is critical that we look at what we should get. At the end of the day, I'm supposed to end up with the tangent of a. Now, we introduce you to several manipulation of the formula, of the double angle formula for cos 2a. Which one am I going to use? The answer to that is in your answer that you should get. You are looking forward to getting tan a. Now, we know, let me put this over here, that the tangent of a is equal to the sine of a over the cosine of a. What does that mean for me? It means that I'm going to be using the identity that gives me sine in my numerator. So that would actually answer the question as to which identity I should use. So with that being said, we can now say, recall the cosine of 2a is equal to 1 minus 2 sine squared a. And this is because cos 2a is in the numerator, and I need to get tan a, which is sine over cos. So sine is supposed to be in the numerator. All right. We also know that for sine 2a, that is only one identity, so it's easy to recall that sine 2a is equivalent to 2 sine a cosine a. All right. So let us input these into my expression now. So my expression is going to become 1 minus, critical that I use a bracket here, 1 minus 2 sine squared a all over 2 sine a cosine a. All right. Let us take this down. Now, expanding my bracket, what am I going to end up with? I'm going to end up with 1 minus 1 plus 2 sine squared a all over 2 sine a cosine a. Let us break this down. 1 minus 1 is 0, so that is gone. I'll be left with 2 sine squared a all over 2 sine A cosine A. And because this is in its factorized form, because 2 sine A cosine A really means what? 2 times sine A times the cosine of A. And 2 sine squared A really means 2 multiplied by sine A multiplied by sine A. We can reduce this fraction. All right, so let me start by taking out the 2. So the 2 is gone. And if I look at the sine A, by laws of indices, sine A into sine A is 1. Sine A into sine squared A is going to give me sine A. So my fraction actually becomes sine of A over the cosine of A, which is exactly what we want. This is equal to the tangent of A, which is what is on my right hand side. If I go back up quickly for you to see it. So now we can conclude that the left hand side is equal to the right hand side, proven true, or I can say QED, that which has been proven. Now here's a second example, and we have stepped it up a bit. Looking at this expression again, it might seem complicated, but all you have to do is remember the identities and apply them appropriately. All right, so once again, we're going to be taking the left hand side. So let me just go up a bit here. So I'm going to be taking the left hand side. Normally, in most cases, we take the side that we can simplify or break down to get the other side, or that is easier to manipulate. And of course, in this case, this is a more complicated side that will be easier to manipulate. All right, now look at the right hand side. We're supposed to get tan A again, which is sine A over cos A. Notice that I have cos 2A in both my numerator and in my denominator. But in the numerator, what I really want to see is sine, and in my denominator, what I want to see is cos. So I'm going to be using both identities. So recall, all right, and let me put this in red. Recall that cos 2A is equal to 1 minus 2 sine squared A. Cos 2A is also equal to 2 cos squared A minus 1. And we know that sine 2A is equal to 2 sine A cosine A. All right. So we're going to be replacing that left hand side there in the numerator and in the denominator with all of these identities here. So let's go ahead. All right, let me go down a bit so you can still see the numerator. So I'm going to have 1. All right, let me put back that in black. 1 minus, open bracket there. And because we want sine in the numerator, we're going to be using 1 minus 2 sine squared A plus 2 sine A cosine A. All right. Let me go down so we can see the denominator here. However, in my denominator, I need to have cosine. So I'm going to have 1 plus 2 cosine squared A minus 1 plus 2 sine A cosine A. In circumstances like this, it is imperative that you use your brackets properly. Now I can just simply go right ahead and expand my brackets. So I'm going to have 1 minus 1 plus 2 sine squared A plus 2 sine A cosine A all over. All right, notice you have 1, you have a positive 1, and you have a negative 1. So that is gone right away. So you have 2 cos squared A plus 2 sine A cosine A. So this is going to become 2 sine squared A plus 2 sine A cosine A all over 2 cos squared A plus 2 sine A cosine A. Now, to finish the rest of this proof, you must remember that whenever we are dealing with trig, think of the algebraic applications that you'd have done if you were dealing with, for instance, an x and a y, or an expression that you had to simplify and you probably had to factorize it. It's the same application that we use. All right, you look for the difference of two squares. Is it a perfect square? Is there something common? Because when I look at this expression in my numerator, I can see that 2 sine A is common. So I'm going to go right ahead and factor it out. That is going to leave me with sine A plus the cosine of A. Similarly, in my denominator, I could take out a 2 cosine A, and that is going to leave me with a cosine of A plus the sine of A. Good. Now notice that my brackets are factorized, so I can actually reduce this. So I could go right ahead and say this into this is 1, and this into this is 1. All right. We could also take out the 2's. So 2 into 2 is 1, 2 into 2 is 1. What I'll be left with here is just the sine of A over the cosine of A, which we know ultimately is a tangent of A. All right. So now we have exactly what we wanted. If we go back up here, that is what was on the right hand side. So we can make our concluding statements that the left hand side is equal to the right hand side. All right.